Hello dear students, today we will discuss how to know that lines are parallel, okay, or perpendicular or coincident, okay. So it belongs to chapter 11 straight lines in plus 2 mathematics first year course, okay. So what are the conditions? What are the under what conditions the lines are parallel to each other? Under what conditions lines are perpendicular to each other? Under what conditions lines are coincident? Okay, we will discuss. Case 1, you see L1 is parallel to L2. Okay, here you see I have drawn x-axis. This is x-axis, this is y-axis, this is origin, right? L1, here L1 is parallel to L2. In case of parallel lines, you know the inclination, okay, angle of inclination. This inclination theta 1 is equal to theta 2, right? Theta 1 what is equal to theta 2. So which implies tan theta 1 is equal to tan theta 2, right? That means symbolically we can write m1 is equal to m2. Okay, so if two lines are parallel, then result will be m1 is equal to m2. That means slopes are equal. This is the result. Conversely, we can prove that if slopes are equal, you see, if slopes are equal, then you see that means tan theta 1 is equal to tan theta 2, which implies simply theta 1 is equal to theta 2. That means L1 is parallel to L2, right? So we learned two concepts. If L1 is parallel to L2, then slopes are equal, and if slopes are equal, then L1 will be parallel to L2, right? Then you see case 2 you see L1 is perpendicular to L2, right? Perpendicular means L1 makes 90 degree with L2, right? L1 makes 90 degree with L2, or you can say L2 makes 90 degree with L1. You see here x-axis, this is y-axis, right? This is origin, okay. So you see here theta 1, let L1 makes theta 1 angle with x-axis in positive direction, right? That means in anti-clockwise direction. So this is theta 1, this is 90 degree. So this will be 90 plus theta 1. Understand? You see, let slope of L1 tan theta 1 is equal to m1 say, okay. Here you see slope of L2, you will see slope of L2. tan 90 plus theta 1. Okay, L2 makes 90 plus theta 1 angle, right? But in anti-clockwise direction, okay, so tan 90 plus theta 1 is equal to m2, say. Okay, so which implies sin 90 plus theta 1, that is equal to cos theta 1, by here cos 90 plus theta 1 is equal to minus sin theta 1, that is equal to m2, right? So which implies minus cot theta 1, you see, minus cot theta 1 is equal to m2, which implies tan theta 1 is equal to minus 1 by m2. Okay, very simple. Here minus cot theta 1 means what? Minus 1 by tan theta 1 is equal to m2. So which implies tan theta 1 is equal to minus 1 by m2. So from 1 and 2, you see, from 1 and 2, you see, tan theta 1 here m1, here tan theta 1 is equal to minus 1 by m2. That means what? m1 is equal to minus 1 by m2. Understand? So which implies m1 into m2 is equal to minus 1. Okay? So we found if L1 is perpendicular to L2, then product of slopes of lines, two lines, okay, is equal to minus 1. Its converse statement, what? If product of slopes of two lines is equal to minus 1, then L1 will be perpendicular to L2. Very simple. Proof is very simple. Okay, m1 is equal to m2 is equal to minus 1. So which implies m1 is equal to minus 1 by m2, right? And we can go from this concept, we can go from this concept to this concept, right? This concept to this concept. Okay, so we can prove it. Very simple. Now, so we found two concepts. What? If L1 is perpendicular to L2, then product of slopes will be minus 1, and if product of slopes is equal to minus 1, then two lines will be perpendicular, right? Now come to case 3. Understand? Come to case what? 3. Case 3. What? L1 and L2 are coincident. Okay, that means they are what? Equal. In simple general meaning, they are equal. Let's say two lines L1, L2. I have taken 2 points A, B. Okay. So under what conditions we can say L1 and L2 are coincident? Okay, are coincident. Under what conditions? Very simple. What? We can I can prove it. Very simple. You see, you see, right? Two lines, okay, two lines. This is L1 and this is also L2, right? Now you see this is x-axis, this is origin, this is y-axis. So this is, let's say, this angle, what, in anti-clockwise direction. Let's say this is theta, right? Here, so two lines, L1 and L2. You know, between any 2 points, let's say here A and here B, between any 2 points we can draw one and only one straight line connecting 2 points. So we say the two lines are coincident. You see, you should understand that the two lines are coincidents. Actually, one line is present, but in mathematics, in the language of mathematics, we are saying the two lines are coincident. Okay, that means two lines are equal. That means one line is present, okay, but it seems as, it appears as two lines. You should understand, okay. So what will be result? You see, we will see. So what slope will be? Slope of L1 is equal to tan theta, okay. Slope of L2 is equal to also tan theta. So slopes will be equal, okay. Slopes will be equal. So if L1 and L2 are considered, then slopes will be equal. Now you see, we can understand in graph that two lines are coincident, okay, but without tracing the graphs, how can we know that two lines are coincident? Okay, it is not sufficient to prove that two lines are coincident, that what, slopes are equal. If slopes are equal, two cases may arise, okay. Two lines may, what are the two cases? The two lines may be parallel, or two lines may be coincident, okay. So we will have to take more things. We'll have to add, we'll have to find more things to show that two lines are coincident, okay. So you see, let's say example, you see, you see L1 and L2, you will have to take 2 points, okay. You will have to take 2 points. Steps are what? Take 2 points, 2 points on L1. You will have to take, you will have to find 2 points on L1, the coordinates of 2 points on L1. Okay. After finding the coordinates of 2 points on L1, then you will have to put the coordinates of 2 points on L2. Then put on what? L2. Okay. If coordinates will satisfy the equation of L2, if 2 points, okay, if coordinates of 2 points will satisfy the equation of L2, then we can say the L1 and L2 are coincident. Understand? Very simple. You can understand. You see example. 3x plus 2y is equal to 0 say, and again another equation, let's say 6x plus 4y is equal to 0. You see, you will have to take what? 2 points. You see, x is equal to 0, so y will be what? In this equation, first equation, x is equal to 0, so y will be let's say this is 1, let's say 1, okay, this is 2, so x is equal to 0, y will be what? 1 minus, sorry, 1 by 2, right? So we found 0, 1 by 2. It is the point on this equation L1. Okay, first equation. Okay, first line, first straight line. Okay, another point you see, x is equal to 1, putting 1, that will be, so y will be what? Y will be 1 minus 3 by 2 is equal to minus 2 by 2, that is equal to minus 1. So here what? 1 minus 1, another point. Okay, 2 points, 0, 1 by 2, 1 minus 1. Okay, so now you will have to put the coordinates of 2 points in this equation. Okay, you will see, what? We will put now. Okay, we will put now. You see, 6 into 0 plus 4 into what? 1 by 2 is equal to, here you see, here 2, right? Okay, right? So this coordinate of this point satisfies the equation 2, and you see another coordinate, another point 1 minus 1. Okay, you see 6 into 1 plus 4 into minus 1, what? That will be 2, right? Okay, so this point, the coordinates of points satisfy the equation 2, right? So now we can say what? Now we can say the 2 lines, L1 and L2. Here L1, okay, L1 and L2 will be coincident. L1 and L2 will be coincident. Okay, so for coincident, what are the conditions? First, you will have to take, you will have to find the slopes. If slopes are equal, Understand? If slopes are equal, then you will have to take what? You will have to take what? The 2 points, the coordinates of 2 points, then put the coordinates on two equations, then if it will satisfy, then we can say two lines are coincident. Okay, perhaps you have understood it clearly. Later time we will more discuss more about this. Okay, thank you very much, and if you are facing any doubt, you may convey me in comment box so that I can make you understand. Okay, thank you very much. Bye.